Okay, so in this example, we're asked to find the volume of a solid obtained by rotating the region bounded by y equals x cubed, y equals 8, and x equals 0 about the y-axis. Okay, well, let's start just by trying to visualize that region. All right, so I'm going to actually just draw a y-axis, and I'll draw an x-axis down here. And y equals x cubed kind of looks like this. It grows, oops, it doesn't curve back on itself. Let me see here. Let's see. All right, so there's y equals x cubed, roughly. All right, so now we're also, okay, that's one boundary of this region. The other is at 8, so let me see. 1, 2, 3, 4, 5, 6, 7, 8. All right, so let's say that this is about 8, so don't want it to be too straight up and down. So here's 8. All right, so that's roughly what our region looks like, because it's bounded by x equals 0 is the y-axis, right? So that's x equals 0. Here's y equal 8, and then this is the curve y equals x cubed. Okay, so it's this region here between the y-axis and the curve. And we're going to rotate this around the y-axis. Okay, so we got this, we're rotating it around the y-axis. All right, so what's that going to look like? We can kind of draw the mirror image over here. Let's see if I can draw it decently. And then we can look at what, let's see, there's 8. And then we can draw, we're rotating it so this top is going to become a circle. So we're going to draw a disc on the top. All right, so that's kind of what it looks like. It's kind of this bullet-shaped thing. And if we draw like an individual disc, let's say we draw an individual disc here, down here, then I can draw a little disc and give it some thickness. So you can see, that's what one individual disc looks like. And the radius of that disc is whatever this x value is, and the thickness is delta y. All right, so let's think about what the volume of one of those discs look like. So the volume, let's write it down here, of one disc is pi times the radius squared, which is essentially x squared, delta y. Okay, but I've got delta y, right? So I would really rather have x in terms of y. So if I rewrite this, y equals x cubed means that x is equal to the cube root of y. All right, so I can rewrite that as pi times the cube root of y squared delta y. Okay, so now if I just add up all of those little discs from the bottom, when y equals 0, all the way to the top, then I'll get the volume of that solid. So we need to integrate from 0 all the way up to 8. And we need to integrate pi, and I'm going to write this cube root of y squared as y to the 2/3 dy, right? And so that's easy enough. That's just a kind of a reverse power rule. So I'm going to get pi, and then the integral of y to the 2/3 is going to be 1 over 1 plus y to the 2/3, which is going to be 1 over 5/3, which becomes 3/5. 3/5 y to the 2/3 plus 1, which is going to be 5/3. All right, and we want to evaluate that from 0 to 8. All right, so what do we get when we do that? So I'm actually going to pull this 3 pi over 5 out front, and then we want to evaluate y to the 5/3 at 8. And so the cube root of 8 is 2, and then we have 2 to the 5th, which is 32. And then when we evaluate it at 0, it's just 0. So now if I multiply that out, I get 96 pi over 5. and that's our volume.